I'm honored to introduce someone who has dedicated his career to ensuring the safety and resilience of the structures we live in. Joining us today is faculty Senthil Kumar from NIT Trichy, a renowned expert in structural engineering with special expertise in seismic design of structures. Welcome to the show, sir.
Thank you, Prem. Thank you for having me in this wonderful session.
So, sir, there are lakhs and lakhs of homes being built all across India, right? And I've seen people spend a lot of money on interiors, on the tiles that they are using. But I also see there is a gap that is being built where people are not understanding the importance of structural integrity while building the house. What's your opinion on it?
Yeah, obviously right. As a human beings, obviously we will first attracted to outside beautiful aesthetics things only. That is not a fault about it actually, right? I just want to use one proverb from Tamil here. Which one is better one we have to take it up. Like, சுவர் இருந்தால்தான் சித்திரம் வரைய முடியும். Mean is nothing but when you have a wall, then only you can do the paintings, right? This is related to our human body health. Like when you are healthy, then only you can do multiple works, all kind of works. That is a direct meaning for that. Same thing I can use it for our building structures. Like if building is stable or having more strength or something, what we can say, then only you can do all kind of alterations like aesthetics and interiors or tiles and everything, right? So those things will change every 5 years, once in a 5 years, 3 years, because our thought process will change, our thinking will change, our taste will change. But when you construct the building once, that's all. It's going to be final. If you want to change it, means what you'll do, you'll add one more floor or something. That's all. But here, the strength of the building lies on the what you have done on first stage itself. So now you can tell which one is best one, or you have to consider as the first one.
Understood, sir. So, can you elaborate more on the structural integrity side?
Yeah, actually, talk about structural integrity, we are having two different types of building systems. One is load-bearing system, another one is frame structure. A load-bearing system means the load on the slab. We have two elements are there. One is slab. Whatever the loads are coming on the slab, it will directly transfer to the walls. That is the old condition what we have done in the masonry, from walls to the foundation. Then frame structure, we are having a slab, some slab to beam, beam to column and foundation. Then it will transfer to the soil, entire load will transfer to the soil. So the thing is, we have to look on many aspects. First of all, soil, because the entire load is going to transfer to the soil only. So we should do the geotechnical test or soil investigation test such that the soil is able to carry that much load or not. That is the first step we have to do. And then the loads are going to be there in the building. So these are the structural elements: slab, beam, column, foundation. This has to be designed for the corresponding different type of loads. So for that we have to do the analysis. Then we will do the design. Here design means arriving the dimension of beams and column, then how many bars are required in terms of RCC construction. For steel structures, it is different. What is the dimension of the beam? For example, ISMB 200, ISMB 250. That's a dimension only we used to arrive. These are the things what we used to call as a structural design. The structural design has to be done for the corresponding load. Then that is based on from the analysis. That has to be done by structural engineering.
Very interesting, sir. So, across India, as you said, that soil is one of the very important things, right? And I feel as if across India there are different places where you can construct a house. Would they be constructed in the same way, or would it be different across India?
Yeah, it's a very good question. Actually, even one particular place itself, soil profile itself will be different. So there itself, the design of structural elements will vary. So when you are changing the zones or when you are changing the places, for example, whatever we are doing construction in Chennai, it may not be possible for it's in Ladakh. So why I am saying is, we are having two different type of loads are there. That is called wind load and earthquake load. This wind load and earthquake load will vary based on different type of locations. For example, in coastal area, wind load will be more. For fault areas, the seismic load will be more. So for that, obviously we know that whenever the forces come, you have to give more strength. So the design will vary. So structural design will vary. Correspondingly, we have to adopt construct the buildings for their corresponding designs.
What's the most significant force among these?
Yeah, actually, I will just take one example for that. Just assume this is a structure, okay? When you are having a building like this, assume the dead load and live load. That is a gravity load. So here I am applying. See that the structure is very much stable. Instead of that, that earthquake and wind load that we used to call as the lateral load, see what is happening? The structure is becoming unstable, right? So from itself we can understand the most significant or vulnerable to the structure is wind load and earthquake loads. So the design for seismic load is totally indifferent than what we are doing for normal actual compressive loads.
So, sir, can you explain me more about the live earthquake loads?
Yeah, actually, first, how you can do the design for earthquake load as a building system is, please take this as an example. Here, this is a beam, okay? This is a column, this is a foundation. Assume we are having beam column connections a 90-degree angle right now, and this bracing is to avoid the out of plane deformation, okay? So, we are going to do some demonstration for lateral load or such that earthquake load. What I am going to do is, here we are having one wonderful concept is there in terms of structural earthquake resistant design. That is nothing but strong column, weak beam. That means we voluntarily making beam has to fail such that we are having more ductile nature of the failure mode in the building. I will let you know what is ductile mode of failure in terms of demonstration. Please see here. First I am just applying the load. See the deformation, it is very less. The building is stable, right? Just I am applying the lateral force. Lateral force is nothing but earthquake forces are called lateral force. I am just applying. See that? No issues. But now what I told you earlier, we are designing as a structure, strong column, weak beam. So after some time, continuously force is increasing. What will happen to the beam is, the cracks will form. Okay. But even though the cracks are forming, beam won't fail. It will continuously take the loads. I am just applying, keep on increasing. See now what happened is, the deformation is more compared to previous. Because what is the reason is, the beam got some cracks. So the stiffness got reduced. So the deformation more now. So now entire load is now taken care of by these columns, right? The more force is transferred to the column. After final sometime you can see that at ultimate stage, if I am going to keep on increasing the force, what will happen is the entire section is collapsing. So you can see that first itself it is having very less deformation. Next still keep on I am increasing the force, beam is getting failure, but that failure is ductile failure. Then it's transferred to the column. Again it is also ductile failure, then it is fully collapsed. So this mode of failure we used to call as a ductile mode of failure. So to get the ductile mode of failure, I will let you know what is meant by ductile mode of failure is, if the structure is suddenly collapsed, people won't get any warning, right? So if you have some kind of deformation, some cracks are there, they will get some kind of ample warning, right? So when you're having that deformation is more, before collapsing means people will get some warning, they can come out quickly. For that only we are doing this kind of ductile thing. So to assure this ductile failure in structure, we should have ductility in member and same kind of behavior in material also. So the material should be more ductile. Then only I can use it for member, then member to the structure to achieve this entire thing.
So talking about materials and construction materials in general, I feel as if any construction material used to build a house is the backbone of the entire building that I would be constructing, and it will stay with me for the next 25 years, right? So the one thing that I've heard about construction materials which to be used are TMT rebars. So why are TMT rebars so special?
Yeah, it's a very good question. Actually, in general, most of the buildings what we are constructing in India is RCC construction. It's nothing but reinforced cement concrete construction, right? So it's we are having concrete inside. We are putting the rebars in there. Rebar means reinforcing bars, right? So the reason behind the concept is, if I am using the concrete as it is, so concrete is very good in compression. When I apply compression force, it's very good. But if I apply some tension, it is not that much enough capacity to take care of the tension. So for example, if it is a beam, as RCC beam, if I apply the bending, top will be in the compression, bottom will be in tension. So if I am using the same concrete, instead of putting a rebar, assume if I am having only concrete as a specimen, if I apply the bending, top is in compression good, when bottom in tension, we don't have any kind of warning, it is failing. That is called brittle failure mode. Instead of that, I am using tension side steel. Assume I am having one more beam. It's not don't think as a full steel beam. Concrete is in the top, bottom I am putting the steel rebar. What will happen is, in applying the bending, see that it will go continuously bending. It will show more deformation. So people will get to know, okay, so bar is trying to bend, it is showing some warning, we have to do some repair work, or we have to come out. Those kind of warning you will get it. Okay, so to get the ductile failure mode, to get that warning, obviously we have to use the bar. So bar should be more ductile. Okay, that is a major thing.
So as a consumer, if I want to buy a rebar, how would I know that this particular rebar that I'm buying is the best for me?
Yeah, actually, whenever you want to buy some product, yes, right. We used to see one kind of logo, always ISI logo, right? So everywhere, all the products will be there. For us, you want to buy a rod, also obviously the ISI logo will be there. They have to follow some standards to use the rebar in construction field. Okay, so to use in the rebar, we are having many properties it has to satisfy. For example, Young's modulus or nothing but modulus of elasticity, and then yield strength of the material, and ratio between ultimate to yield strength, and finally elongation, that is nothing but ductility. Okay, these many parameters we have to check it out as in terms of mechanical properties, and then chemical composition. These are the major thing we have to check, and these two things should be followed as per IS 1786 codebook. In that standard clearly mentioned, if you are using FE 415 bar, this much value should be there. FE 500, this much value should be there. FE 500D, FE 550D, or FE 550. How much percentage elongation should be there? What is the ratio should be there? What is the Young's modulus should be there? Everything will be there. And also, they might have given you the chemical composition also. Because based on the chemical composition, the strength and ductility will vary. So for corresponding, if you want to get higher strength, higher ductility, what is the chemical composition? It should be there. That also mentioned there. That is in IS 1786.
So how do I know that these such properties exist in a rebar which I'm buying?
Yes. So if as a customer, if you are planning to construct one building, so you are going to buy a rebar steel, rebar, what you got to do is go to the vendor and get one rebar, 1 meter of sample. Just do the go to the renowned lab nearby. Any institute or any enable accredited lab, just go there and ask them to do the tensile testing. So the tensile testing will be based on IS 1608. So they will do the testing. That is nothing but I'm having a rebar, I'm going to pull it. So when I'm pulling, what will happen? It will take a load, and obviously steel, it will try to elongate. It won't fail quickly, it will try to elongate. So for each load, what will be the deformation will happen in the steel? That we used to find out in terms of the lab. That we will discuss it in a direct lab also. I will take it to you, and we can see how to do the testing there. And from that we will get the graph. From the graph, I will let you know what are the things we have to take care of it in terms of these properties. Yeah. Actually, we are doing the testing, tensile testing, compression, bending, all kind of tests we can do. As I discussed earlier with you, like to find the proper material for TMT, you got to do certain kind of tests. This is one of the best first test you got to do to find the mechanical properties of the rebar. Okay. Yes. From what we are doing here is we have to take one sample and just pulling like this. It will expand. Okay, when you are applying the load. That is the thing we are going to do here, and the marking and everything is based on the procedure given in IS 1608 guidelines. That NIT laboratory people who are all we are going to do this, they will take care of it everything. Only thing what consumer or customer has to do is they have to get the one sample, minimum 3 sample, not only one sample, 3 sample from the vendor, and they have to give it to that NIT accredited laboratory. Okay.
So basically, this will pull the rebar
and
it will show what sort of a graph will it show?
Yeah, it's when applying the pull, right? Yeah, it's continuously taking the load. So in y-axis you will have the load. In x-axis we will have the deformation or deflection, what we say. So when you continuously pulling, it will try to elongate, right? That displacement we used to put it in the x-axis. So you have x-axis and you have y-axis. You will get the curve. From the curve, you can find all those properties what we have discussed, like Young's modulus or nothing but modulus of elasticity and yield strength. That should be a 0.2% proof strength, because all the bars what we are using is HISD bars. So that won't have any distinct yield point like FE250. Nowadays we are having all the bars are HISD bars. So when you want to find yield strength, that should be corresponding to 0.2% of strain, what we are saying. For 0.2% of strain, we have corresponding strength that is called 0.2% proof strength, that is equal to yield strength of the material. So for example, if I am testing 550 bar, the yield strength should come minimum 550. Okay, and also we have to check that yield value is 550. Continuously will take more load. That will be ultimate tensile strength. That only I told you the ratio between ultimate tensile to the yield value. As per IS 1390, it should be minimum 1.15. That means ultimate to yield value should be 1.15, or we can say other words, ultimate value should be more than 50% of this yield value. And finally, what we discussed continuously about one point, that is called ductility. The ductility you can calculate based on the elongation. How much it is elongating. So as per 1390, it should be minimum 14.5% elongation that you can calculate from the final length to the original one.
So we'll now calculate the elongation.
All those things.
Perfect, sir. You can go ahead and start. So that was so amazing that we saw in the lab about the tensile test and all the tests that you showed with respect to the rebar. Just one thing, as a consumer, which TMT rebar grade and variant am I supposed to go for to build my own house?
It's a very good question. Obviously, every customer would have that kind of question because we are having so many options in the world now. As we discussed and as we seen in the lab, so I will suggest 3 important things we have to take care of it in choosing the rebar. First one is chemical combustion. It should be as per IS 1786. And the other 2 things are when you take care of these 2, obviously everything will fall in that thing. When you go for high strength and as well as very good ductility, go with Fe550, and also for ductility, go with the super ductile material. So when you have Fe550 and super ductile material, it will solve all the problems mostly.
That's very interesting, sir. So to wrap the shoot up, just a couple of things. What tips would you give a home builder like me while choosing a rebar, and general construction practices tips for a consumer like me?
Yeah, actually, what are the problems I have faced during the construction? The mistakes are when you are choosing the stirrups or doing the centering of the stirrups and everything on some type of sites. What is the major problem they are facing is they always go ahead with the 90-degree connection. So what will happen is whenever we are going with earthquake, even normal loads also, this will be the big problem because that stirrups hook should be not less than 135 degree. Okay, so it should not be as a 90 degree because if I am having only 90 degree hook, obviously it will come out. Why we are providing stirrups is it holds the main rebar as well as it will give the shear strength for the concrete. If the stirrups is not there, if it is come out, what will happen to the concrete? It will become shear failure. The shear failure is not like a ductile failure, what I shown earlier. It's a brittle failure, like earlier we showed, sudden failure will happen. So to avoid that, obviously you have to go with the proper hooked stirrups. And another thing is, I just want to say major thing, it's a maintenance part of you. So whenever you are having the terrace, so it's accessible, please maintain the terrace continuously, provide a proper slope as well as provide proper DPC. Because the thing is, the water seepage through means it will lead to the many problems for the structural elements like corrosion, all those things and all. So this also should be taken care of in the construction.
Thank you, sir, for joining us on the show. I think now our consumers know why structural integrity is really important and why these particular rebars, particular tensile strength, Young's modulus, and these specific things are important while choosing the right rebar. And I think, sir, you gave a lot of helpful tips to the consumers also with respect to choosing the right grade and variant. Thank you, sir, for joining me on the show.
Thank you, Prem. Thank you very much.
To summarize, we have seen how structural integrity is as critical as interiors and aesthetics when building your dream home. While aesthetics enhances comfort and appeal, a robust structure provides the safety and durability that forms the foundation of everything else. A holistic approach ensures that the home is safe, robust, and long-lasting, dream-worthy construction. Proper analysis of the soil ensures the right type of foundation is chosen, providing a stable base for the structure. This is the first step in ensuring the building can support the overall load efficiency. Beyond the foundation, the structural design must account for the load-bearing capacity, durability, and resilience to the forces like earthquakes, etc. Designing structures to withstand earthquakes is a critical aspect of modern construction. The role of high-quality materials like TMT rebars form the backbone of any structure, providing strength, ductility, and resilience. The IS 1786 standard serves as the benchmark for selecting the appropriate grades and variants. In conclusion, FE550 SD TMT rebars emerge as the clear choice for building your dream home. With their unmatched strength, advanced durability, and exceptional seismic resilience, they meet every critical requirement for modern construction. By choosing FE550 SD, you lay a solid foundation for your dream home, one that stands resilient, secure, and built to last for generations.